He only given us this opportunity as he had done his internship in our company about a few years back. So without further ado, I'll start.
Okay.
So basically, this is our little bit of a history about our organization. We have been in the industry for the last 50 years. So we had started off basically as a company manufacturing exclusively insulation products. And then slowly over the years, we moved into switchgear and cable accessories. So if you look at us as an organization, we have customers across various sectors in mining, manufacturing, utilities. We also have done select export jobs to countries in the UK, Australia, and the Middle East. So one of the main reasons why we have survived for such a long time, over 50 years, is because we have a customer-centric approach and we have strong technical capabilities. So right now we're in the process of building a new facility, and it's almost ready for completion, and we're moving our production to that facility within the next 1 or 2 months. So this is just a brief timeline about our organization. We initially started off with 3 partners, and we exclusively started with insulation products. So then if you see over the years, we established more facilities. In 1972, we built a vacuum plant for casting. And then in 1987, we started forward integration by moving into MV switchgear. So in those days, there was a lot of import substitution going on. So we developed one of the few players in India to develop epoxy resin insulators way back in the 1970s. Then as we moved over the years, the common core component in all our products, whether it's insulation, switchgear, and cable accessories, is epoxy resin insulators. So in a way, we have done a little bit of forward integration over the years, from starting from insulators, then moving on to MV switchgear, low break switches, isolators, and finally up to VCBs, vacuum circuit breakers. So in 2014, specifically for Bale Rudrapur, we have developed a 150 megawatt generator bushing, and it's type tested one. I think in India, we are one of the few players to have the special type of generator bushing capability. So now the next step is we are moving into a new facility. So these are just a brief overview about our products: switchgear, offload isolators up to 33 kV, motor control centers, and insulation. Specifically, this presentation will be focused mainly on insulation. So we've done epoxy bushings, resin cast insulators, FRP tubes and supports, generator bushings, and FRP cylinders. Cable accessories we're not going to touch upon, but we have also manufactured cable accessories like slip rings, earth switches, junction boxes, and those kind of products. So now coming to insulators, right now in our field of electrical industry, the main 2 insulators used are the porcelain insulators and composite insulators. Now, A-Bond Strands is specialized exclusively in manufacturing epoxy resin-based insulators and filament-minded FRP tubes. So now all these products, they have certain advantages over porcelain insulators. They're lighter in weight and have higher strength. And now in most indoor applications, epoxy resin insulators are the go-to product. So now, like I mentioned earlier, as a case of forward integration, most of these insulators are used in our other products like disconnectors, circuit breakers, and load break switches. So now just a basic understanding of epoxy. The term epoxy is derived from epoxide. It is basically a technical name which describes a specific arrangement of carbon and hydrogen atoms that terminate their molecules. Now, what are the good qualities of epoxy resin insulators is they have good dielectric strength and they have good electrical properties, which is why they have more acceptability nowadays in lots of switchgear industries in indoor applications. So the creepage distance in these insulators are easily modifiable. These can be done with the help of shreds. Now, why the shreds are used is because you have to avoid flashover distance between earth and face. Flashover is a very common problem that's happening. So this has to be addressed in the manufacturing phase itself. The ranges of insulators we manufacture range from 6.6 kV to 33 kV. Now, when it comes to the voltage rating, the dimension of the insulator plays a key role. Now, without understanding the dimension, we cannot go in for deciding the voltage rating of the insulator. Another important aspect is the cantilever strength. The strength of the insulator is a very important factor, and it can be increased by increasing the length of the bottom insert. Next slide. It's just a basic cross-sectional diagram of our epoxy insulator. It has a few technical specifications like creepage. material, ambient temperature rise, and this is basically 11 kV insulator. It's just a small picture of our flight. One is a CAD drawing of our epoxy insulator, and another is just the various sizes of film, 6.6K, 33 kV. So now coming to seal-off bushings, which is another insulator product which we manufacture. Seal-off bushings have a wide variety of applications. They're used in transformers, they're used in tap changers, also used in various switchgear. So now specifically when it comes to switchgear, they use a lot in bus ducts. The main reason they use in bus ducts is they help in preventing leakage of hydrogen, and which is incoming from the generator terminals. Now, when compared to porcelain bushings, epoxy resin bushings are much stronger and they're much lighter in weight. They're also the more durable when compared to porcelain bushings. Now, specifically from a manufacturing perspective, they have more design flexibility because they can be molded into various profiles and shapes, which is not possible when it comes to porcelain bushings. And the tooling we just use in epoxy bushing is also very less in cost when compared to porcelain bushings. It's just a slight 3D profile of our epoxy bushings. Now coming to material characteristics of epoxy resin insulators. So basically epoxy resins come under the family of polymers. They're thermoset polymers. So they have unique characteristics like cross-link network structures. These network structures formed exclusively by a covalent bond. Now these thermoset polymers are stiff and brittle materials, but one unique advantage of them is they are stable at elevated temperatures and they are resistant to solvent and other chemicals. So now when it comes exclusively to manufacturing perspective, it has a few advantages. It has low residual stress, very less pure shrinkage, and also has low pressure when it comes to manufacturing these products. So they can be used in a wide variety of temperature ranges. Then and they also do not melt upon heating. So most of the times when we heat up these material, it doesn't only beyond a certain point the decomposition occurs, but it's very stable under most temperature ranges. So the unique capability of thermoset polymers is they are shaped as per the mold. Now the curing process, it is very important in the manufacturing process of these thermoset polymers. The chemical reaction which is used to initiate the cross links, this only helps in ensuring that the material takes a permanent shape. This process of cross linking is called curing. Now it's actually very similar. The process of curing of a thermoset polymer is very similar to baking a cake. It is exclusively influenced by thermal energy. So it's very similar. The process of doing this is very similar to baking a cake, actually, for a very easy understanding. Now, for polymers, when it comes to manufacturing, you use various components. We use curing agents, additives, polymers, colorants. These are all mixed in various compositions to get the desired profile. Now, once the mixture is heated to cross-link levels, it's then cooled and then and then after that you can remove it from the mold. So most these thermoset polymers, which they're mainly used in switches, circuit breakers, and insulators, which is what lots of industrial applications which we're using it in. So now when it comes to epoxy resin families, the main two are aliphatic resins and cycloaliphatic resins. Now when it comes to cycloaliphatic resins, we have noticed that when it comes to manufacturing applications, they're more useful for outdoor kind of applications and high temperature applications. This is because they have a particular molecular structure which has higher resistance to UV rays and they have excellent thermal stability. Another advantage of cycloaliphatic epoxy insulators is that they weigh less than porcelain insulators and they're much more durable than porcelain insulators. And they easily can withstand high power arcs, mechanical shock, and also ultraviolet rays. We're actually currently in the process of developing cycloaliphatic based product for defense application. It will be used in an outdoor application. So that I think probably later this year, this product will be in production. So now when it comes to the manufacturing process of our insulators, the first main process is the mixing process. So this mixing process for the epoxy insulator, the main components are the resin, hardener, silica powder, plasticizer, and accelerator. So the mixing ratio for all these components is at a ratio of 100:100:300 to 350, 10:1. Now there's a slight variation when it comes to this thing. When it comes to it depends on the quantity of silica powder. Actually, sometimes can vary, because sometimes it can vary depending upon the density of the resin. So now these components are mixed in the correct ratio in the mixing plant, and the silica powder is actually used to increase the mechanical strength. The accelerator, the main purpose of it is used for gelling. The plasticizer is used for avoiding cracks in the component. Now the ideal pressure at which the composition is mixed is under 1 bar vacuum, and this is mainly done to remove voids in the mixture. The voids are very they can actually reduce the performance of the component, so it's essential that the voids are removed during the mixing procedure. Then after the mixing process, it's transferred to the molding tank, and the resin is then preheated. The mold is preheated with the help of air pressure. The gelling time can vary from 10 minutes to 120 minutes depending upon the component size. The gravity casting. Now this is there are two types of casting. We have pressure gelation and we have gravity casting. Now gravity casting is mainly used when the later production is very low, and also when the mold cost is low. The main disadvantage of this method is the changeover time is quite high, and the manpower requirements for this method are also quite high. It is quite a simple procedure. The resin is just poured into the mold and it's pulled down into the required profile by gravity. After this process, the assembled mold is placed into the oven. The oven usually operates at a temperature of 130 degrees. The mold usually in this case is made of aluminum, and in case of the inserts, the brass and copper bars are fitted into the mold. So now pressure generation is slightly different when it comes to gravity casting. Pressure generation is used when you require batch production or continuous production. So during pressure generation, the resin is continuously delivered to every mold under pressure, and this helps in eliminating the voids. As I mentioned earlier, voids can decrease the performance of the component. So in this method, the mold is mounted in the machine along with heaters. The heaters are placed behind the mold and they operate at a temperature of 130 degrees Celsius. In this method, the brass inserts are placed between the molds as required. Now both the halves of the mold are closed under a lot of pressure by hydraulic pressure. The resin is injected in the mold by air pressure. The air pressure value is around 1 to 2 kilogram per centimeter squared. So now after the gelling process, the component is released from the mold. Then again has to undergo curing in the oven. The time duration for this is around 480 minutes. And the main reason is the curing process is important because it increases the electrical properties of the insulator. As I mentioned earlier, one of the advantages of pressure gelation over gravity casting is that the aesthetics of this method is quite good. Changeover time is very less, and the manpower requirements are also very less for this method. So these are some pictures for the molds required for the Sela bushing. This is a picture of pressure gelation machine and the oven which is used for curing. Now, what are the tests required for insulators and bushings? So power frequency test is a very important test. It is used to check whether the insulator can withstand a dielectric test strength. Insulation resistance test is also used to check whether the resistance value. Partial discharge is done to verify the life of the component. Impulse is done to verify creepage and clearance between face and earth. Now, after the electrical tests are completed, we have to undergo the mechanical tests. Cantilever tests, compression tests, and tensile tests are done. So, compression test is done to check the maximum breaking load of the insulator. Tensile test is done to check the maximum tensile load. So, this is a picture of a testing apparatus. This is a power frequency test. Now, when it comes to generator bushings, it is the main component in the power generation plant. We manufacture various range of generator bushings. Our lowest range is 110 megawatt. Now, what is the important feature of generator bushings is that they have to operate in a continuous mode, which is why they have to be provided with the air or gas cooling system. So now, high voltage bushing comprises of an insulator. It also comprises of a conductor and a mounting flat slit over the insulator. So now, the insulator in our case, we are using a composite material rather than porcelain. In our case, we use epoxy resin. So this is very crucial. This is a small picture of our generator bushing. It's a 3D CAD file. So now, what is the manufacturing process used in our generator bushings? In our generator bushing, the copper tube is the conductor.
Hello, sir. Hello,
Yes.
sir. This is a small question. So I saw that the generator bushings, the conductor was hollow.
Yes.
Can you go back to the previous slide?
Yeah.
Yes, sir. So this the conductor was hollow. So is it actually hollow or is it a CAD representation?
No, it is actually
It's an
Okay,
actual hollow
sir.
tube. It's an actual.
So why is it hollow, sir? Why can't it be a single conductor?
Because this particular thing is filled with hydrogen. This
Oh,
particular
okay.
conductor inside is filled with hydrogen. So
Yes,
that is
for
the
Okay, so we need
for
to
cooling
pass the
purpose.
hydrogen inside.
Yeah,
Okay.
you can see in the, if you can see the big, at one end there is a nozzle-like thing. You can see
Uh-huh.
there's a nozzle-like. That's where the hydrogen is filled.
Okay, okay.
Okay, so that's why this particular application, where you have to cool
Okay,
from
sir.
inside, hydrogen is filled into the conductor, and it has to be
Mm-hmm.
absolutely leak-proof. And also on top of that, we do the insulation so that
Mm-hmm.
the insulation capabilities are also taken care of, and also the practical application of the hydrogen cooling happens. These are for the
Okay,
big
sir.
one.
Understood.
You got the point.
Yes, sir. I did. Thank you very much.
So now the first step is the brazing process. Then the copper tube is the main conductor in the generator bushing. It has to first be subjected to sandblasting. Now, why is sandblasting done? It is to ensure there is proper addition of the epoxy resin with the fiber roving on the copper surface. So once the sandblasting process is complete, we can start the filament winding process. Now in filament winding process, we do, apart from the regular filament winding, we do condensing bushing method. In the condensing bushing method, the difference is we apply one layer of epoxy, after which we apply another layer of aluminum foil. Now, why is this done? It's usually done to improve the electrical properties of the bushing. So actually, in our first, when we were first initially manufacturing generator bushings, in the old process, we only used to do filament winding. So actually, this had some drawbacks as we used to get flashover during the testing phase. So now, when we went back and redesigned the generator bushing, we added an additional method called condensing bushing. So when we added the additional condensing bushing along with the regular filament winding, the product would should flash over without any external vibration or noise. So that's why we do the additional condensing bushing method. So once the winding method is finished, now we can go for machining. Once post machining, we have to apply another clay coating of epoxy resin on the aluminum flange. Now, why is the flange used? It's mainly used for mounting purposes in the generator system. So now, after the flange basting process, we have to undergo all the regular tests like pressure test, power frequency test, partial discharge, tan delta, and impulse test. The mechanical test we have to undergo the cantilever strength test and has to withstand the pressure of 1 ton. Now coming to FRB tubes, my colleague Mr. Parshati will explain. Before that, I just want to add tests like sir, these tests like which he just described, partial discharge and tan delta. These are to test the porosity of the bushings or the component. If there are, so that the casting or the component has to be absolutely void free. So for better dielectric strength, not only for electrical strength, it should be absolutely void free. The purpose of this test like partial discharge and tan delta is to establish that it's as void free as possible.
Yes, sir. I am Parsharthi. I am dealing with FRP tubes and supports. Okay. FRP tubes are fiber reinforced plastic in composite material made of a polymer matrix reinforced with fibers. FRP tubes are used in insulator applications in power transformers for inbuilt tap changes. FRP tubes has a lot of advantages like corrosion resistance, high strength, and withstand high temperature. Good mechanical properties and electric properties and good measurability is also there in the FRP tubes. And then this is the what we are manufacturing the FRP tubes. I have shown some pictures of it. And then the manufacturing process of FRP tubes. That is mandrel cleaning and preparation. Mandrel is like that. We have to wound that epoch that.
I just see we are for our epoxy for our manufacturer, we are following a process called filament winding. Filament winding is the world accepted practice wherein
we got various strands of fiberglass are wound round a particular mandrel at a certain various angles to achieve both electrical and mechanical strength. I will just to go through the process. You have the mandrel. A mandrel can be steel. It's basically steel plated cylinders around which we wind. Before we do the pre-treatment, mandrel is cleaned and waxed. The purpose of cleaning and waxing is so that when we release it, the release will be, it is like a release agent, and the release will be done in a smooth manner. Then the resin is mixed in a separate chamber to a predetermined ratio, and then at a certain temperature. Then the resin is poured into the resin bath, and then the filament winding is done. That is, the strands of fiberglass go through a resin bath and then are wound onto the mandrel at a certain angle. This angle will predetermine the mechanical strength of the component. We adjust the angle we have because we have a drive which controls the motor, and by varying the speeds we are able to adjust the angle of winding. We have got our name A-Bond Strands from this process only, wherein we bond strands of fiberglass on a certain mandrel and achieve. This is how we started in the old days. After the filament winding process is done on the mandrel is on the machine itself, post-cured to a certain temperature for a certain duration of time. So that it's very essential, the post-curing process, because that only will be able to retain the mechanical electrical properties of the component. After the post-curing is done, we take the cylinder, we take the mandrel with the cylinder and put it in a chamber in an oven for further post-curing, and after that we extract the cylinder from the mandrel. Now, removing the cylinder from the mandrel can be done in various ways. Abroad, we have things like collapsible mandrels, but we are following just the fixed mandrel from which we remove the cylinder. After that, in some cases, the external surface of the fiberglass cylinder is machined. Abroad, they don't use the machine. They take the mandrel and they take the fiberglass cylinder and use it as it is. But in India, some clients insist on this machining process. We machine it and finish it, and you get the final component. We have given below the mandrel how the whole procedure, which I don't have to repeat. It's there for everybody to see. The mandrel is first cleaned. The mandrel is first cleaned, and we apply a release agent on the mandrel. This is done for the easy removal of the fiber tube from the mandrel. Using the dimensions of the component, we can estimate the amount of resin required in the process. The pre-weighted quantity of resin is now heated at a temperature of 45 to 55 degrees. The resin hardener and accelerator are mixed thoroughly, and they are mixed at a ratio of 100, for example, 100 to 85 is to 1.5 to 2.5. This mixing ratio depends on the type of resin which we normally use, and it can also vary depending on the resin system we adopt. The composition is now poured into a winding machine bath. The rovings have to be dipped inside the bath. The resin dipped rovings have to be wound around the mandrel to get the desired dimensions, like the outer diameter and length. The continuous fiber reinforcement provides the structural core required for the final component. The fiber is key as it is the primary contributor for the mechanical strength and stiffness of the composite. So, the fiberglass will give the mechanical strength, and the resin will give the dielectric strength. The main components of a filament winding machine are the mandrel, the job holder, the delivering eye, and the control system. The mandrel used for our machine is water-soluble mandrel. The advantage of mandrels is that it's a low cost of production and quantities that are small, and it has excellent repeatability. The job holder is also vital. It is mainly used for the operation of holding the mandrel on which the reinforced matrix is to be laid, on which a process is going on. The job holder acts like an axis. The similarities are drawn to the mirror head and tail stalks, similar to a lathe machine. The delivering eyelids is an important component based on the type of winding method and patterns. It effectively decides the place of or delivery point of the reinforced matrix. The control systems comprise of mechanical, electrical, electronic integration to a common interface. Whatever I described earlier, this is basically the whole thing. The filament winding system is integrated to a Honeywell universal controller. It's basically an AC drive. The fiber creel is a structure that stores at the position of a large number of fiber packages, and it provides a mechanism of orderly fiber payout. The filament winding method used is a wet winding type. Wet winding involves passing of the fibers through a resin bath and winding the fibers on a rotating mandrels simultaneously. Leak pressure is an important parameter to be measured in case of FRP composites. The other parameters that play a key role in affecting the manufacturing process are filament type, that is the type of rovings. Fiberglass comes in the form of rovings. It can be 600 tex, it can be 1200 tex. Then the winding angle and winding temperature. As all these parameters can be controlled through the controller. We are just giving a basic diagram of this process. If any of you have questions, we can answer it later on the filament winding. Now, to get different types of components, you can have multi-axial winding also. For the jobs which we are doing, we don't have a multi-axial winding machine. Nowadays, you get multi-axial winding machines which are CNC controlled and are very sophisticated. This type of process is also used in the manufacture of not only electrical items, but even missiles in various countries, and even DRDO is using this for manufacturing of missiles with fiberglass shells. Winding angle is one of the parameters that can affect the manufacturing process of filament wound FRP components. Winding angle is measured between the rotating axis and the fiber. The fiber wetting system used in our system involves setting and maintaining the winding bath temperature at 50 to 55 degrees. It is recommended for the impregnating the resin bath. The curing cycle after takes in a controlled heating oven at 140 degrees. After the winding process, the mandrel is placed in the oven for a period of 180 minutes to 240 minutes. The oven is heated at a temperature of 135 to 145 degrees. If the mandrel diameter is above 300 mm, the mandrel is pre-cured in a rotating oven. After the pre-curing process is complete, the FRP cylinder will be removed from the mandrel. Then it is again placed. Now, how it's removed, I just want to say through a mandrel extractor. Then it's placed in the oven for post-curing. Once the post-curing is complete, the component is ready for machining. The outer diameter, length, and components are controlled in the machining process. Some of these machines used are also CNC lathes. After the machining process is complete, a resin coating is applied over the cylinder. This is done to avoid etching and a proper uniform finish. This is just a view of the whole process. First, the mandrel is cleaned, and then the release agent is applied, as you can see in the photo. Then we give an inner layer of tissue cloth, and then the winding is done. This is the finished FRP cylinder. This is how the winding is kept. The machines you can see on the top are the fiberglass. It's called cheeses. Fiberglass comes in the form of rovings, and these roving cheeses are kept in a chamber. I've kept it outside just for display purpose and for you to get idea. And the right is the final finishing of these FRP cylinders. Now you know why are we making these insulation products? This is used, we have vertical integration in various panels made in our mother division. It can be in terms of support insulators, the insulators in the switch. You can see that wall mounting isolator wherein we have these epoxy insulators located on the switch. Now, the only problem, is with epoxy, as already mentioned earlier, is it can be used only in indoor applications primarily. The reason why is epoxy reacts with UV rays and the properties get deteriorated. When epoxy is, to combat that, nowadays there are new systems come into the market, which is, and these resin systems are called cyclohalifatic resins, which, and also non-hygroscopic resins. These prevent the deterioration of and are used outside for outdoor applications also. Unfortunately, its cost is prohibitively high and people are not going for it in a mass scale, though it is coming in. Now, here are some of the products we make wherein we use our insulations inside. On the left is the switch 11 kV switch fuse unit panel. Then we have we go up to 33 kV load break switches. We have a full lineup of 11 kV 7-panel VC board, a motor control center for mining machines, and a wall mounting isolator. This wall mounting isolator is a very interesting application. Inside a steel plant, they want to save the cost of the enclosure. So they mount the switch at a height and have the operating rods come down to operating level. That way they save the cost of a panel in a huge steel plant. I'm just giving a list of some of our customers. It's basically the who's who of Indian industry. In mining, you have Coal India, NMDC, Triveni Earth Movers, South Eastern Coalfields, Bharat Earth Movers, Navali Lignite, Singareni Colliery. Since you're recording this, I don't think I should read out the whole thing because it is self-explanatory. The idea of giving is a segment-wise, when you come to manufacturing, it is basically all the OEMs, including, for example, the Volkswagen car plant. They're fully powered by our panels. Even the hospitals, we supply our panels too for hospitals, hotels, anywhere where the primary source is medium voltage electricity. And given the steel segment, which is also very clearly given all the industries which we are supplying, we have done a little bit of export. A lot of government agencies also are buying our product. One interesting application where since you are IIT Kanpur students, we have supplied all the panels for the substations in IIT Powai. In all the substations in IIT Powai have got our load break switch fuse panels of a 22 kV rating. This has been in service for more than 20 years. Just for an example purpose, I'm citing this. With this, we conclude the official part of the presentation. And thank you for giving us this hearing. If there are questions to be asked, we are prepared to take it. By the way, my name is Reddy. I am the managing director of the company. I am Prabhasa's father also. So we are prepared to answer your questions. The only thing is for students, we would like to add something. After you, I would like to give a small thing after you, if you have any questions.
Thank you, sir. Thank you for sharing your knowledge on health monitoring of performance and asset management. The segregated case studies were very interesting. I kindly request you to share your experience regarding career prospects, which may include in academia, industry, or postdoctoral programs, specifically for the benefit of PhD students in the field of high voltage engineering. As you mentioned that you will discuss this afterwards after the Q&A session. So we'll open the Q&A session to audience now. If there are any questions, then
yeah, could you please
hello, sir.
A little loudly, please, if you don't mind.
Yes, sir. I have a question. I have few questions actually. Like while you prepare the bulk epoxy resin insulators, then while mixing, also there some voids may happen because you are preparing the epoxy resin based material in a bulk. So how you are avoiding creation of voids, and how do you check that voids have not been in the insulator? Like
So
if
you're
there is
asking
any
how do
way.
you prevent voids? You're talking in
Yes,
you're talking about the epoxy casting or the
yes.
filament? The epoxy casting,
Epoxy casting.
yeah, basically because we are casting it under vacuum, right?
Okay.
So because the
Uh-huh.
vacuum, we take the vacuum up to a certain bar, and the vacuum, and we then cast, if we pull the resin into the mold, So because of the vacuum pressure, the voids are generally getting, they automatically get removed. First of all, we are injecting the thing through pressure gelation process under vacuum. The resin is
Okay.
first mixed under vacuum and injected. Have you heard of plastic injection molding? This is something similar to that only. The reason for
Okay.
so the vacuum, it is mixed under vacuum. So that is
Okay.
the main.
It is that means while preparing the bulk epoxy under vacuum condition, the voids automatically gets eliminated.
Yeah.
I mean,
So that you get, and
okay.
also just for your technical, there is one word which I'm sorry I've not addressed in this. There is a thing called, you can make a note of this, thin film degassing.
Thin film
Thin
degas. Okay,
film,
degas.
I'm sorry, I didn't present a slide on thin film degassing, wherein inside the mixing chamber itself, you have a centrifugal screw
Okay.
in a cylinder. This is located inside the mixing chamber. So the resin goes through the centrifugal process, goes up and comes down, under vacuum.
Okay. Okay.
So this
Okay, sir.
thin film
Sir,
degassing process makes the resin absolutely void free and
okay.
homogeneous.
Thank you. Yeah, thank you so much. Actually, I'm a student from IIT Kanpur. Actually, why I also prepare epoxy resin based sample and testing. But while because we are preparing sample very small quantity, even that in that also we face the problem of voids. So I thought
Yeah, I think
when
the
we
vacuum, you can you can have a small vacuum plant next to this thing, chamber, and mix it under vacuum. No?
Okay. Sir, I have one more question. Like while in the starting of the presentation, I have seen that there was one slide that about the composite insulators, and while preparing the composite insulators, you have said that you're using silica powder while making it. So, sir, why silica powder? Why not another other powder?
Right,
Have
silica
to use?
powder we use is basically, silica powder is the one which gives this mechanical strength.
Okay.
See, in
So,
the filament, the purpose of silica powder is, as against just a pure epoxy casting, is it gives you the mechanical strength. Nowadays, many people are buying pre-filled epoxies also, wherein the silica powder is mixed by the resin manufacturer itself, rather than being done by us and given to us, so that we eliminate one process. The purpose of silica powder and fiberglass in the filament winding process is to give the mechanical strength to the component.
Uh, and sir, silica powders are like micro size powders or
Yes, it comes in a
nano?
very fine powder. It 300 mesh. 300 mesh is
Okay.
the this thing, and there are guys who are making this. There are many guys making this. They are called mineral manufacturers. They make a lot from
Okay.
them. We buy.
So this composite insulators are already in the industry. People are using it.
Yeah. This
Okay.
composite is used. It's not our product. And earlier, now every company has got, like, it's every switchgear company will be using these insulators.
Okay.
And every switchgear company, and it's also used, this process is also used for instrument transformers also.
Okay.
That is like current transformers and potential transformers.
Okay. Okay. Thank you, sir.
I would request everyone to fill up the feedback form that is shared in the chat. And also, I see that Ms. Pratasha is having a question, I guess.
Yeah, hello. Thank you, sir, for the talk. I have one question. Um, that you mentioned that epoxy insulators cannot be used for outdoor insulation. For that, we need to use
There are certain epoxy systems called
okay,
cyclohalifatic.
okay. So, sir, can you tell me more about it? Like, what are those? Like, how do we prepare that? How much epoxy do we take, or
No, no, no,
is
no,
it
no.
lab prepared?
All these resins which come primarily we buy it from Huntsman Resin. It's a multinational company. All
Yes.
they will give you a cyclohalifatic resin. They will give you a data sheet. If you want
Okay.
later on, I can share you these data sheets, okay, of what the properties are, and they'll give you very strict procedures how to manufacture.
Mm-hmm.
That is the resin hardener ratio.
Mm-hmm.
It's just that the properties of the resin are different from general epoxy resins.
Okay.
That's why, so that it can be used for outdoor purpose.
Mm-hmm.
Now in Western countries, they are going for it in a big way because again, see the main problem is outside insulators with porcelain are the brittleness. Correct?
Yes, sir.
What you see on the road and what you see on these electrical poles and all that. The main problem is the brittleness.
Mm-hmm.
So to avoid that, only we are using now they're going in for this cyclohalifatic resins, and with that they make these epoxy insulators. But the cost, unfortunately, is prohibitively expensive. See, in India, unfortunately, as you go practically speaking, no, you are all students. I want to share one thing. Everybody, they want to have Benz car quality. They want a Benz car quality, but when it comes to paying, they will pay Maruti car price. This is the sad thing,
That's true.
They want to have a Benz car quality. They want the best things. They write all the technical specifications and all that. But when it comes down to brass tacks, when it comes down to the actual thing, they will want Maruti car price. How will that work? They want everything. This is the main problem. So what I want to share is, especially for your PhD students, few points. Can I talk about it now or later? If you finish your question, then I'll share those points.
Yeah, and sir, one question out of curiosity. You said that in IIT Powai you installed the insulators. So what was the insulator material there?
We installed our insulators in our switches. We made a product switch
Okay.
fuse units, and these
Okay.
panels were in the various wherever there was a transformer, to control the transformer, they had various substations throughout the campus. Our
So
panels.
they were not epoxy based, were
It was
they?
epoxy. The epoxy went into the switch gear. Of course, it was epoxy based. It was the switch gear. It was basically an indoor application. The panels were put in the substation and kept at various things inside throughout the campus.
Okay. So, sir, how did it encounter the humidity problem there? We know that Mumbai is very
It was
humid.
not a problem because our panel is also we test our panel we test our panel for indoor. It will be IP55. That is a degree of ingress protection. All our panels, we have the switch, the epoxy insulators go into the switch. The switch is fixed in a panel, and the panel is designed for ingress protection, IP. So there are various degrees. If it's an outdoor panel, if it's located outside, open to the atmosphere, you need to test it for IP65.
Okay.
If it's for indoor and located inside a substation where there is already a building, for inside a building and all that, you need IP55. Nowadays, even your phone and watch and all that, your Samsung phone, all that advertised, no IP65 or IP70. No, this is just the degree of protection. So when there is no degree of protection, ingress protection, that's when you use a cyclohalifatic resin for outdoor. When you just put the insulator barely exposed to the atmosphere.
Okay, sir. Thank you, sir.
Okay. Next question. I have some few practical points because I also did my master's in the US. See, the difference here, unfortunately, is we are very, very theoretical. In our in all our institutions, I'm not saying it's your case, when the practical knowledge is very, very important. Whatever you study in theory, unless you can use that theory, practically, what's the point? So what
Yes,
I'm
sir.
saying, as much as it can be, you must be all brilliant having going to IIT and all that. But unless you see the practical side of things, only then you learn to appreciate. I see we are supplying, and even in steel making, for example, I went to a steel plant once. Whatever you learn in your textbook, when you actually see it makes a lot more sense. That's one point. And then the second thing, which is totally what I'm going to say is totally a little bit off center, is all of you should learn whatever you can't say in one page. You should improve your soft skills. How to write a letter. First question I asked you, how to write a simple letter. You get many of these students who come are brilliant. They're very good academically and all the India I'm talking. But when you ask them to compress their thoughts in a 1 or 2 page letter, many people flounder. It's very, very important that whatever your thoughts are, you should be able to. Your soft skills are extremely important. This is not only for your PhD students. Even in India, why the American doctors are our Indian doctors are very good. Medical doctors. But then in America, to do a medical degree, you first have to do 4 years of undergrad, and then you have to go do 4 years of. Sorry?
Himanshu Gupta, please mute.
Okay.
Sorry, sir.
So my only request is that all of you, whatever you do, improve your soft skills, because this will go a long way. That's what we were in America. They teach you that, which they don't teach us here in schools, and colleges. Huh?
Thank you, sir. Thank you for your insights and discussion in this broad spectrum on solid insulations. And also you have shared your industry experiences, which means a lot for us. Sir, I have a basic question, like condensing bushing you talked about. So can you tell a bit about it? How is it different from filament winding and all?
Which one, sir?
Condensing bushing, you have told that you are following a new method of.
The condenser bushing is we basically first wind a cylinder. Okay. I'll take you back one sec. See, this is a condenser bushing. It's a matrix, First we wind the cylinder, right, on the conductor. It's a hollow conductor. We wind the cylinder.
Yes,
okay. So the cylinder has already got some electrical properties. To improve that, because around the cylinder, we give a foil, a layer of foil, aluminum foil. This is for the what is that? The purpose of the foil is
from the aluminum foil only we get the earthing point.
So the earthing, the purpose of so that the earthing is properly ensured. Around that we cast the whole thing. After that in epoxy. So this particular bushing, condenser bushing, has a combination of both filament winding and epoxy casting.
Okay, sir. Thank you, sir.
Right.
Any more questions if we have? Otherwise, I would request all the participants, if possible, to switch on their camera so that we can have a group photo in the form of a screenshot.
Hello, sir. I have one question.
Yes,
Yeah.
sir, please.
This is Himanshu from IIT Kanpur. Sir, you talked about this FRP composite. So I have one question. When we are using composite, so we have seen that phase charge is the problem due to difference in the two material properties. So have you done any assessment, lifetime assessment that may degrade the performance in the longer term by charge accumulation?
For what accumulation, sir?
Sir, I am talking about especially for composite material, this fiber reinforced composite you talked about.
Yeah.
So like phase charge from point of view, the charge accumulation because of this interface.
Charge accumulation.
Yeah. So any lifetime assessment, because the charge accumulation definitely will be there because of difference in the two material
Generally
properties.
speaking, in all our components, we give it a lifetime of basically at least minimum of 10 years, sir.
Okay.
Minimum 10 years. Depending also on how the operating conditions are, no? See, in India,
Yes, sir. Yes,
unfortunately,
sir.
there is, all these go in various products, right? In India, unfortunately, there's one word which is not very great. That is preventive maintenance. If the preventive maintenance of the entire product is done well on the panel, then it shouldn't be a problem. It will last quite a bit.
Okay. Thank you, sir.
Okay, if there are any further questions which which you are not satisfied with our replies or anything, you can send us a mail at our email address, which is A-Bond Strands at. I'll just send. Please send any questions. I'm just adding our email address in the chat. You can.
Yes, sir. We got it, sir.
Yeah, and also one more thing, I'm opening this thing. Any of you want to come and do an internship here, yeah, you can please get in touch with us. We are moving to a new factory. We always encourage that kind of support. Any of you want to come and do an internship here or anything, and they're most welcome. Only problem is we are sitting in Chennai and you are in Kanpur. Yeah. And also anything in cyclohalifatic, any new things which you'd like to develop, work with, we are more than happy to work with you. We are looking at a new area down the road. Basically, you might have heard of this South Dakota School of Mines. One of the researchers got there in South Dakota, we are working on a carbon fiber project. So if any of you guys are interested going forward, keeping in touch, do stay in touch with us. Keep in touch. We shared our email. And if you have any further questions or anything, we are more than happy to answer to the best of our ability. I'm not saying whatever we say is going to be absolute, but we'll try our best.
Thank you, sir. Sir,
Yeah. Sir,
yes, ma'am.
I also have a question related to industry and academia. Like the students who are doing PhD, after completing PhD, they think that in India we don't have opportunity to join industry. So, sir, would you like to say something about it? Like,
Yeah,
is it
definitely.
true
There's
that?
so much of there's definitely a lot of opportunities in industry. Okay, whoever said that there is no, the best way out is while you're doing your PhD, now do an internship in some of the many companies nowadays accept it. Try to do internship. There are so many companies like Tata's and all that. Try to do a practical internship simultaneously. That itself will give you a good thing.
Okay.
Now,
Actually, sir, specifically in case of high voltage area, people think that there is no industry where you can, after completing your PhD, will be able to join.
no chance. There
So
is so many switchgear companies like Siemens, ABB, and all that. They have separate programs. Companies like Schneider, Siemens, the multinationals. If you approach them through their HR, definitely at least an internship you will get. You may not get a job immediately, but I'm quite certain they respond to you for at least an internship. After which you can take it, depending on once you get a foothold inside, these
yes.
guys do definitely this thing. I'm quite confident of that.
Oh, yes, sir. Thanks.
Thank you, sir. Sir, I would request you to just stop the screen sharing so that we can have a group photo and all the participants, and to turn on their camera so that we can have the group picture in the form of a screenshot.
I've switched it on.
I think it's done.
Okay.
Thank you. Thank you.
So it was a pleasure and thank you for having us. Please do stay in touch. You don't know. I always believe that there's something we can find some synergy in working together. If you throw 10 stones, you will hit one mango for sure.
Yes, sir, that's true. Really, it was really nice to have you as a speaker, and we have gained a lot of knowledge from you. Thank you so much, sir.
Stay in touch. Thank you. Thank you. I would
Sir,
like to also
Thank you,
thank
Sir,
Mr. Balaji for facilitating this.
Thank you,
program.
sir. Thank
yes,
you,
sir.
sir.
And pleasure. Thanks.
Sir, it is our pleasure to have you on board as a speaker for the event. And in that regard, please accept the virtual token of appreciation on behalf of the IEEE DEIS Student Run Chapter IIT Kanpur.
Okay. Thank you
I
so
would-
much.
Welcome, sir. I would like to acknowledge the efforts of the entire IEEE DEIS SBC team at IIT Kanpur for planning and executing a wonderful webinar. I also express my sincere gratitude to IEEE IIT Kanpur Student Branch and IEEE UP section for their support. I would also acknowledge Dr. Alok Ranjan Verma, our faculty advisor, and Dr. Nandini Gupta, our mentor, for providing their valuable guidance and support. And no event is complete without a lovely audience. We thank you all for being with us. It has been a great pleasure. Thank you. Thank you, sir.
Thank you
Thank
so
you.
much. Thank you.
So we'll leave the meeting.